We're going to just do the bell work together just to save some time since we are starting late and we have shorter classes. So let's talk about this first one. It says, how many students are there? How do I figure that out from a stem and leaf plot? Jacob.
You count the numbers in the leaves.
You count the number of leaves. You count the number of leaves, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. We have 20 leaves. So we are going to have how many students? Well, we'll have n equals 20. How do I find the mean then? How do I find the mean of these? EJ.
Add all of them and divide by n.
All of them up and divide by n. Now pay attention to this. Would I go 2 plus 4 plus 6 plus 8? No, instead what would I do? What would I do instead of doing 2, 4, 6, 8? Yep. And so on, yeah. 52 plus 54 plus 56 plus 58 plus 61. So I actually want you guys to go ahead and do that if you haven't already. Zeiser.
Check that what it is.
Oh, sure.
I think it's 1,481.
1,000.
Is that right?
Oh, maybe.
481?
Yeah, me.
Did I have that right?
Yes.
And then we divide that by 20, and what approximately does that come out to? 74.1. Yep. Either 74.1 or 74.05, depending on what you round it to. I'm going to stick with that 74.1. All right, now it asks for the median score. I do not want to have to write all of these out in order and count inwards. What can I do to find exactly where that middle is? Labib.
Don't you add them all and divide them by 20?
That was my mean. I'm on the median now, so we have the mean. How do I find exactly where that middle spot is? Yeah.
Can't you add up how many students there is plus 1 divided by?
Yes. Did everyone hear that? Songha, what did she just say? Yeah, let's pay attention. So if I want to find where that central point is, so if I want to find that central point of any set, we are just going to do n plus 1 divided by 1. By 2. So our n is 20, so we do 20 plus 1 divided by 2, which equals 10.5. Now, I just count inwards 10.5. I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 0.5 is halfway between 74 and 74, which is still 74. So that 10.5 gets me that little divide right there, and so our end answer is 74. Know how to do that n plus 1 divided by 2. Because the bigger the set is, the more complicated it's written, the easier it's going to be to know that. Especially yesterday when we were going on that frequency chart that had like 94 different numbers on there. Much easier to know where your middle number is rather than having to count inwards. So know how to find your central point. All right, questions on the bell work? Cool. We're going to go over homework questions after because I want to take a picture of that page so we can go over it. We'll do the lesson first. All right. We're starting with creating a frequency table and a histogram. We've already done this before. We're creating a histogram and a table based upon card prices of cards that were found at Target. So let's go ahead, if you haven't already, complete your frequency chart and complete a histogram. I'll be doing it while you're doing it so you can look up and see if you have stuff correct or incorrect. frequency. Relative frequency is going to be a percentage. In fact, it's usually just a decimal, but we can read it as a percent. And it is the number of times that an event occurs during an experimental trial divided by the total number of trials conducted. In other words, our relative frequency, oh, that's still my line tool. Our relative frequency is going to equal frequency divided by n. Frequency divided by n. Normally when I'm doing a frequency chart, a relative frequency chart, I normally don't have intervals, frequency, and relative frequency. Usually we just have intervals and relative frequency, but you can have ones that have all three. So real quick, let's put down our frequencies. So we had 4, 7, 4, 3. 4, 7, 4, 3. And then we had 0, 2. All right, my relative frequency is our frequency divided by how many items we have. So it's 4 divided by 20, which is going to come out to 0.2, which you could also write as 20%. Well, let's continue down. We have 7 divided by 20 is going to equal 0.35, which is 35%. 4 divided by 20 again, we already know is 0.2, which was 20%. 3 divided by 20 should be 0.15, which is 15%. 0 divided by 20 is just 0, so I would just put 0 or 0%. And finally, we have 2 divided by 20, which is going to equal 0.1, which is 10%. All right, so now I took a sample, and my sample was 35% of cards are between 1 and 1.49. If this was a truly random sample that was big enough, I could then walk into Target and say, hey, 35% of your cards are between this price. So if you'd have like 1,000 cards, we'd have 350 would be between this price, give or take. That would be inferential. Inferential would be me taking this 35% and saying, I'm going to walk into Target and 35% of those cards are between this price. That's inferential. I'm applying it to a bigger population. I do want to talk about something really quick. What do you think this adds up to if I do 0.2 plus 0.35 plus 0.2 plus 0.15 plus 0.1? EJ, it's going to equal 1 because it's 100% of our data. So if I asked you to find a sum of this, you'd come up with 1 or 100%. If you come up with anything else, you probably made a mistake. Perhaps there's a rounding error. Possibly it was rounding and it really wasn't an error. It was just, it didn't work out. All right, but you should be around 100%, if not exactly 100%. If you're rounding weird, it might be 99.99. All right, that is relative frequency. The next thing we're going to talk about is something called a two-way frequency chart. A two-way frequency chart is a way to examine relationships between two categorical variables. So if I look at my two-way frequency table there, I am comparing men to women, and I'm also comparing what's their favorite party type. I guess they're throwing a party and they want to decide who wants what and where. So let's look at this two-way frequency chart. Whichever direction you go, your very end is your total. So if I look at that 6 plus 2, we have a total of 8 people. And if I go down, 6 plus 3 plus 1 equals a total of 10. Let's talk about those totals. So I go 6 plus 2 equals 8. That 8 is the number of people who want bowling or who like bowling. That is the total number of people that like bowling. However, if I just circle that 6, just the 6 portion of it, that is just the number of males who like bowling. So each one of these numbers inside are broken into separate categories. I have 3 females that like dancing. I have 11 females that like skating. I have 10 males, I have 16 males, and I have a total of 26 people. This is your that 26 is your total of total. That is your total number of people or total number of whatever you have. All right, let's use that two-way frequency chart to decide what percent of males prefer bowling. Just tell me how to set it up. I don't need the answer. I just need to know how to set it up. What percent of males prefer bowling? Labib. 6 out of 26. I wouldn't do 6 out of 26. I would actually do EJ?
You would do 6 out of 10.
I would do 6 out of 10. I would do 6 out of 10 because I have 10 total males. It doesn't say what percent of males like bowling compared to the total. It is what percent of males prefer bowling, and that would be 6 out of 10 possible males. So that would be 60% or 0.6, which would be 60% of males prefer bowling. Zeiser.
I said 6 over 20. But I don't know. Do
Do you know where you got the 20 from? Oh, Emma.
I did the exact same.
Okay.
Yeah.
Did you add the 10 at the
Yeah,
bottom?
I mean, I added them all.
The 10's the total.
The 10 is the total.
Yeah. I did the exact same.
The 10 is the total. Don't add any more. That is your total number of males.
I didn't even notice.
So we have 6 that like bowling, 3 that like skating, 1 that likes dancing. We have a total of 10 males. EJ.
For the 26, could you just call that like the sample size or the population depending on?
Yeah.
Okay. Yeah.
This would probably be the population because we might have interviewed 26 people. That would be our entire.
Yeah.
Maybe that's everyone that's attending the party. It depends. Yeah. All right. How many females were in the study? Ooh, that gets the Zeiser. How many females were in the study?
There were 16.
There were 16 of them. There were 16 of them. What percent of people, see how it says what percent of people that liked dancing were male? What percent of people that liked dancing were male? Songhai, just tell me how to set it up.
You see, male over total, so 1 over 4.
1 over 4. Yep, because 4 is our total. It says what percent of people that liked dancing. So the people that liked dancing were a total of 4. What percent were male? Well, one of them was male. So it's going to be 1 over 4, which equals 0.25, which equals 25%. So be very careful when reading these. Be very careful when reading these. All right, are we good on those? Dave, you want to write some of those down? Let's keep our head up. All right, the next one is you surveyed students at a school to determine if they required swim lessons, but part of your table got erased. Uh-oh. Uh-oh, SpaghettiOs. Fill in the missing blanks to create a relative frequency table. Now, you might want to hold on for filling out your relative frequency table. But if you want to, if you do it wrong, you just got to erase everything. All right, what would probably be the first number I would look for to fill in? Zeiser.
Grade 7 can't swim.
Grade 7 can't swim. What would that value be?
60.
It'd be 60. Because I need 120 plus something equals 180. What's the next one I could probably fill in? Someone from the right side of the room. I haven't heard much from you. Yeah, Alex.
The total for grade 9 is 175.
Yep. We would just add all those up. What's my next one? Vaishnu.
The total for grade 8 is 179.
Is 179 because 180 plus 179 plus 175 must equal 534. What can we do next, EJ?
You can find the total that can't swim in 8,
Which is 11 right there, right? Because we have 168 plus 11 must be 179. Well, the rest we can just kind of add up, right? So how many total people can swim?
I don't want to do this. Do it.
You have a calculator right next to you. Yes.
460
460?
Yeah, that's not
And then how many people can't swim? Jacob? 74. A good thing to do is once you fill out the chart, make sure 460 plus 74 equals 534 and make sure that these columns also add up. I'll also check my totals when I'm done. All right, now it says create a relative frequency chart. Now there is only one specific way to do this, and that is to divide everything by the total. At the end of the day, I want 100% down here. So our 100% is right here. So you are going to divide each and every one of these by 534. Let's talk about that really quick. Focus up here, because this is where people make mistakes when they do the relative frequency table. People tend to do 120 divided by 180, and then other people do 120 divided by 460. It can give you a percent of a specific row or column, but it would not be the relative frequency table. It wouldn't be comparing all the values together. In fact, if you picked any other number besides 530, you're going to end up with like 200 to 300% for your percent of people, which doesn't make sense, right? This one should always be 100%. So we're going to divide by our total, which, let's go ahead and fill out this table. This turned out to be about 0.22. Can't swim would be about 0.11, which would mean your total would be 0.33. For grade 8, who can swim, if I would do 168 divided by 534, I'd come out with about 0.31. For can't swim would be 0.02. So our total was 0.34.
3.
Oh, 3.3.
I see what you're
Ooh, was that 3.3? Oh, you know what I did? Yep. We'll go back and we'll talk about that one. So then we do 0.32, 0.01, which came out to 0.33. What does 0.33 plus 0.33 plus 0.33 equal? 0.99. So we actually wanted this to be 1. So what I did is I actually went back and I did 179 divided by 534 and found out that was actually 0.34. So you can either leave it as 0.33 or change it to 3.4 to match so we can have 1 in that column. I kind of did the same thing on the bottom. I had my totals as being 0.86. I had this as being 0.14, which equaled 1. So we run into problems like that 0.034. You have two options. Either change it or leave it as 0.33 and just know they actually add to 1. It's a rounding error. It is because both of our numbers rounded down when one of them should have been rounded up. So we probably have a little error here. So we can either leave it as 0.33 or change it to match our ones. It is up to you. There's no wrong or right way to do that. Yes?
Can you write them as percents or do they have to be?
You can write them as percents, yes. My answer key will be all decimals, but you can definitely do percents. Yes?
Like when shouldn't it be 0.85?
For this one? Yeah, if I just added these straight up, but if I actually do 172, if I do 460 divided by 534, I'd get out 0.86. So that was also one of those that they add to something different, which means you can either go back and adjust it, or you can leave it as 0.85 and 0.14, which would change this one to 0.99, which isn't a problem. Sizer.
So if you know how for relative frequency grade 8 it says 0.34, and then for grade 7 it says 0.33. Shouldn't those two numbers be flipped because grade 7 has more people total than grade 8 on the other side?
On the other side, so grade 8 has 179 people.
Yeah, but then it has a bigger number for total on relative frequency.
It probably should, shouldn't it? The more people you have, the bigger the percent you have is. Yeah. And that's why I picked that one to change. Because this one has more people. It's kind of weird that they're both 3.33. Because you're like, wait a minute, this one had 179, this one had 175. So it was that rounding error. So what I did is I corrected it by saying, you know what, that'd be closer to 0.34 because I do want to show that this one's slightly more than this one.
Yeah, but then isn't the one on the top, grade 7, that's more than grade 8?
Oh yeah, that would be a one that we'd have to switch to, probably. I see what you mean. I see what you mean. I thought you were talking about these two. So this one would probably be a better one to switch to the 0.34, right? In fact, the one thing that would solve all of this is if we went one more decimal place. If we just went one more decimal place, especially if you're doing percents, if we went like 33.4%, 33.3%, 33 point, you'd be much closer to 1. So just know I'm okay. I fully understand that with rounding, we have things slightly different. Either change it or just leave it equaling 0.99. All right? So if this doesn't come out to 1, that's okay. 0.99 is fine. I see what you mean now. I thought you were comparing grade 8 and grade 9. All right, let's go ahead and answer these questions. Now, be careful with these questions, especially the second one. The first one isn't so bad. How many students need swimming lessons? Jacob. 74 do. Ooh, that's still highlighting. What percent of 8th graders, now be careful with the question, it says what percent of 8th graders need swimming lessons? So we probably can't use our relative frequency chart. We probably have to recalculate this. Jacob, you want the second one too?
Yeah, 6%. 6%.
How'd you get that?
You do 11 divided by 179.
179, that comes out to, what'd you say, 6% about? So about 0.06, which would be 6%. Note that we divided by the number of 8th graders because it's specifically asking 8th graders. All right, which grade level needs the most help swimming? Someone new. Come on, it's just looking at a chart and which one has the, Krupa. 7th grader have 60 that can't swim. So we'd say 7th. Dagan, let's keep our head up. I don't care if you're not sleeping, keep your head up. Yes?
So what if, like, a grade has more students that are, well, in this case, can't swim, but what if another grade has a higher percentage of students that can't swim? Like, what would your answer be?
That's a good question. That would probably be one of those questions I say explain.
So would that be opinionated?
It'd be opinionated. Because it says which grade level needs the most help with swimming. So higher percent would be the most help swimming, but let's say I'm someone that's scheduling. If I have to schedule swim classes for everyone, the one that has the most students that need help. So it would depend on what question I'm trying to answer. Am I just looking for percentages, or am I actually trying to schedule? Because it wouldn't make sense if it was like, I don't know, if 50 people in this grade turned out to be 50% of it, and this one had 100 students that can't swim, but is like 40% of the grade. It wouldn't make sense for me to schedule more swim lessons for the higher percent. I would do by student. Did that kind of dance around your question enough till I answered it? All right, good. All right, distribution. That's the last thing we're going to talk about. The distribution of data shows how the data is arranged. We already did one of the 3 ways, and that's center. That's when we talked about our mean, our median, and our mode. Our spread or variation we'll talk about tomorrow. That is standard deviation. That's what we'll talk about, and it's also range. The last one is shape, and that's what we're going to talk about right now. Shape of graphs. These 3 graphs are the most prevalent histograms that you'll see across statistics. So much so that each one has its own specific name. So notice our first one. We have a bulk of our data on the right, but it kind of strings off to the left. This is called skewed left. Our next one, it looks like our data is in the middle, and it kind of reflects on both sides. It goes out about the same spacing, or let's just get to the word. It's symmetric. I was trying to think of another word for symmetric, and it just wasn't coming to me. Symmetric, this is also called a normal curve.
How many F's in symmetric?
2.
All right.
I have 2, so hopefully it's 2.
That's 2.
All right. Normal curve. So if data being skewed to the left looks like this, then the other one must be right skewed, or skewed right. All right, we're not getting into super detail on this, but we're going to get to one important fact. Let's go back to mean and median. I have a mean and median. Which one is less affected by outliers? Mean or median? Which one's less affected by outliers? The median is less affected. So we actually know approximately where our mean and median are in relation to each other. These are small blips. These are kind of like outliers. They're not part of our main information. They're skewed out here. So what actually happens is those numbers pull your mean further left, where your median would be closer to the bulk of your data. So if you are skewed left, it means it pulls your mean further, and the more skewed it is, the further your mean is going to get pulled. And your median is going to get less affected. It's going to be closer to the bulk of your data. For symmetric, since it's being pulled in both directions equally, your mean and median are going to be about the same place. Your mean and median are going to be about equal. Obviously, they won't be 100% equal for most things, but they'll be in general about the same. All right, the last thing we're going to talk about is skewed right. Skewed right, the mean is going to get pulled right. So your mean is going to be more right than your median. All right, real quick, let's go over those homework questions that weren't posted. Let's see if I get the right page. I think it was page, that one. 8, 9, and 10. Let's take a look at those guys. Eight, 9, and 10 weren't posted online. All right, guys, 8, 9, and 10 are up there right now. The one I really want to go over is reading dual stem and leaf. Our first question is, what is the age of the youngest actor to win an Oscar? And you also had actress. I added actress to that. For actor, your youngest actor was 31. For actress, your youngest actress was 21. What is the age difference between the oldest and the youngest actress to win an Oscar? The oldest was 80. The youngest was 21, so it's just 80 minus 21, which equals 59. The last one is, what is the oldest age shared by 2 actors to win an Oscar? I would have accepted 60 because there was an actress and an actor. That's 60? I know it said actor, but I mean actresses really are actors. I don't know. But the correct answer, the answer I was looking for, Jacob, what was the correct answer I was looking for? I was looking for 56.
Wait.
The question was geared towards 56 because it says directly actors.
So you mean 2 guys?
2 guys.
Okay. I thought we were talking about
What if you're
one
talking
each. Because then I said.
If I'm talking collectively, I tried to delineate between actors and actresses. I probably should have put male actors, female actors, I guess,
Yeah.
if I wanted to get correct. But I was looking for 56, but I would accept 60. Answers will vary on this one. Answers will vary on that one. I will look over your answers tomorrow because unless I'm reading this wrong, we are done. We are done and have